right, we are on to the most important part of the program, which is the startups and the startup talks. As announced, we have some pretty exciting things for you today. More than things, some of them are people. First person, Aron Acosta, co-founder of Rise Robotics. Amazing man. I'm not going to say anything more. It's a good guy. Aron, your stage is yours.
Good morning. Yeah. So Hollywood has done a really good job convincing everybody that Terminator is here to take our jobs and then kill all of us. And I think what we'll begin to see is that robots are just tools that empower humans. And so we're really clear at Rise that our purpose is to empower the human body. And we believe that this next movement of robotics will largely be about empowering the body, because the chips have done a really good job at empowering the mind. 1 second. I'm gonna grab this. Cool. So the team got to know each other at MIT. I met Blake in some robot building competitions, and we did some projects together. And then we rounded out the rest of the team based on the skills that we needed and cultural fit, an obsession for building really hard things. In order to make the products clear to the world, we brought on a Rhode Island School of Design industrial designer, and that's Kyle. And then lately we've been tuning and preparing for mass production of the air compressor, which I'll talk about midway through the presentation. So before we started Rise, we worked on projects like these. Out of the MIT Media Lab and the Biomechatronics group. There was a moon buggy project that Kyle worked on at Rhode Island School of Design. Blake made some fascinating bearings. I'm happy to talk about any of these in detail if you come find me afterwards. Basically, we like building mechatronic products, and we did it just for the love of it. This was our hobby. And then we were fortunate enough to gather together and raise some money and build some really important prototypes that launched our company. And this is really the feeling that we're going for, right? We think that exoskeletons for rehabilitation are important, and so are commercial lifting devices to reduce injuries on the job site. And we believe that exoskeletons will go on to do a lot of different things, but in the same way that Henry Ford realized that in order to excite the masses and spread the technology, he had to build the sweepstakes race car. We believe that what will bring exosuits to the masses is actually fun, and that fun fuels utility. And we've seen this with electric cars, because lots of electric cars have been attempted to be made, but if they're not cool, and if they're not a roadster, then nobody cares, right? So hoverboards are another great example where Segway-type technology is extremely successful commercially. And even the bicycle was actually originally a toy, right? So we believe that fun will fuel utility, and this is what inspires us to work on really hard problems. So why don't we have this yet? There's a lot of problems, but one of the biggest ones is actuation. And specifically, it's power per pound per dollar. Right? If you can't make a hydraulic unit affordable and low weight, then you're not going to be able to move massive loads quickly. And if you can't make a servo strong, same problem, right? So there's this very large gap between servos and hydraulics that we're filling with a new type of actuator. And by doing that, we can make robotic manipulation powerful and affordable. So this is the Cyclone drive. And basically, we spread out forces so they're even. And there's no Hertzian contact where you have these large pressures. And that enables us to use low-cost materials and low-cost manufacturing methods. So we can tune the Cyclone to be competitive with ball screws, a precision machined piece of metal. But if you don't care about exosuits and you don't care about actuators, you probably care about making businesses profitable, like I do. And so you kind of have to start considering where to put it. So at first we're like, well, this could go everywhere. This could go in things that lift things. This could go in things that pressurize things. But the problem is that it was everything for everybody, and so it was nothing at all, really. It was just some drawings. So, and this is a problem that robotics suffers from. One of the things we talk about at RISE, in addition to fun, fueling utility, is that the robotics industry is where companies start and then often die. But when they grow up, if they do, they usually mature into a specialized area that isn't robotics, right? So eventually it just becomes a vacuum. Or it eventually just becomes a laundry washing machine. And the robotics are your roots, and it might be where you hire from, but it really isn't your industry. And going to the industry and trying to sell an actuator, a new one especially, was quite difficult, and we weren't making very good progress. So we looked at the history books a little bit, and we found some other things that inspired us, like transistors. And transistors also suffered in the early days. They couldn't commercialize, nobody knew what it was or why you wanted to use it, until this thing called the radio came along, the transistor radio. And then it was kind of obvious that we could do a lot of other things with this. So we focused the Cyclone Drive on air compression. And what you're seeing here is a cyclone down the middle, and then just some air cylinders like you would see in a bike pump. And because the Cyclone Drive is a linear actuator, we can have really long strokes, which means we can have really large volumes, and we can pump air more slowly and more coolly. And that leads to some really cool benefits like quiet, lightweight, fast, long-lasting air compression. So we're taking this product to market with one of the largest power tools in the world. It's going to launch at home improvement stores as early as next year, depending on what our partner decides. And we focus on what we're best at, which is the design and the engineering, right? So that means that we need to partner with other people who are really good at the other parts of the business. And so our next steps, as this partnership becomes public in a few weeks, are to succeed with them, because that's our transistor radio. And without a breakthrough market success, there's really no reason for other companies to join in and apply the Cyclone to their products. After that, though, we're looking for our next product partners, and we're looking at things like tables, standing tables, flight simulator chairs, hand cart dollies, and in general, mobile products that have to move a lot of mass, right? Have to move a lot of energy and do a lot of real work. And then eventually that brings us back to exosuits, which the hardest part, we believe, is the actuator right here on the back. And we're well on our way. Thank you.
Thanks. Next up on stage is Sampriti Bhattacharya, who is the founder of Hydroswarm. And she told me a very interesting story about how she got to MIT, and I thought it was pretty instructive, and she'll tell it better herself. But she said something to the effect of, I was attending this community college in India among millions of others, but I wanted to do something in the US, and I sent out 500 applications for internships in the US. 3 of them, or 5 of them responded. 1 of them worked out. And I don't think that was at MIT, but it was somewhere in the US. And then there's probably several cycles of the same process of intensity of will and willpower. And so that's one way to get to MIT. And I guess it explains a little bit why she's in front of us today. Stage is yours.
Nice. Hi, I'm Sampriti. I'm a PhD student in MIT Mechanical Engineering, finishing my thesis, and founder of an early stage startup called Hydroswarm. We build small underwater drones for maritime big data and ocean exploration. And today, I wanted to talk about the oceans, what lies beneath the surface, and essentially to inspire a conversation about things that we probably don't think about all the time. So let's take a look at the blue world. I mean, 70% of our world is ocean, and even today, we know less than 5% in any great details. That is less than what we know about our moon surface. And as we talk about the depleting resources, we worry that where to find the next energy jackpot. So we think about mining the asteroids or going to the moon to find helium because there's like $1 trillion worth of fuel out there. But what we forget is in our backyard, 90% of the world's energy, life forms, and resources are there, terribly underutilized. So I just wanted to really think, convey what is the big problem when it comes to ocean? Like, why haven't we explored it as much? And there are a few. But first, what I want to say is that I used to be an, aerospace engineer before, and ocean is not rocket science. It's just a little bit much more harder than doing space in many respects. So what's hard is that in the ocean, unlike in the air, you don't really have high-speed wireless streaming videos and stuff. Radio attenuates essentially, so it doesn't work. You use ACOMs. Pressure is really hard. It crushes you. And the third is that there's not much of light, right? In hundreds or 1,000 meters depth, you can't see. So there is no map even, right? Nothing, you don't have GPS working. And I'll give you a few examples which will make it very clear what I'm talking about. So if you remember this accident, which was like finding the Malaysian Airlines, right? A giant 737, and we use many things. We use ships, we use, airplanes, and so on. And we also used, in the US side, we use autonomous underwater vehicle, a Bluefin 21 out here. And it's a big one, and it's multi-million dollars also. And what we were trying to do was trying to search an area of 120,000 square kilometer. This particular mission was actually 26,000. And for an airplane, just to listen to a ping. And this guy goes at 5 nautical miles. And the director of Phoenix International, who carried out the mission, even he knew that this is not even the right tool for the right job, because it's just not optimal. So $130 million after, and after 2 years, I get to hear that robots taking over, but hey, we don't even have tools to find a massive 737 airplane in the ocean right now, and it's 2016, right? So, yet if you break down to the physics of the problem, right, think about what was I trying to find? I was trying to hear just a ping. And to hear a ping, all you needed was a bunch of hydrophones, $10 hydrophones, that's all. And a bunch of them should have been distributed around, area of interest. But something doesn't make sense because I can't put a $10 hydrophone on a $3 million vehicles and have hundreds of $3 million vehicles. So back to the big problem. The big problem when it comes to ocean is that even today, we do not have a method of mapping or monitoring large-scale ocean areas in a cheap, cost-effective way. But this is just one example, right? People remember this, the BP oil spill. And even today, you are going out on a ships or wave gliders or whatever it is, and trying to, in many cases, manually take samples and measure the pollution. And this was around $20 billion, including many things, a cleanup cost. But why not have a distributed chemical sensors that could have just tracked the periphery of the oil spread, right? And this is something I'm personally even passionate about, is coral reefs, which contribute about $30 billion to the economy, the global economy. And you ask that, why are they dying in some places, and in other places they're doing okay? And that requires comparison of massive amount of data, for example, in one coast to the other, right? But there's no way of doing that because we don't have large samples of data very easily available. Last but not the least, let's talk about aquaculture, fishes. It's gonna turn into about a $200 billion market by 2020, that's the prediction. And the problem is that I've talked to a lot of people in fisheries, and the thing is, how do we, have a cost-effective, cheap method of optimizing my, fish farming? So there's a lot of examples. And one more, probably very relevant to this place, is defense, Navy. Question is that you're in the airport and you know there is amazing airport security, right? Do you ever think about seaports? Like, how do you really monitor all these small, large ships that are coming in and out? And how do you know that there is not a little bit of threatening stuff hidden in some of the cavities, right? So this is a marine mammal program by the Navy SEALs, where out here in San Diego, in fact, not too far, where they actually use seals or even dolphins with GoPro and backpacks and many things, and they go out and sniff any kind of terror threats on the ships, because what you can do is that you can bring in a lot of things with the ship. But the point is that how many dolphins in the world are you going to train? It's hard to scale. So that's what I want to think, is that there is a potential out there. There's a clear need in the market, and we probably need to think and now, because what's out there is this. We have expensive, large, or big, or localized, and the big problem with that is that none of them is, all of them are mission specific and not scalable. But it might remind you of a familiar thing, right? Like the aerial drones, which used to be Predator flights, they used to be very mission-specific once upon a time too, till they turned into something that's so adaptable, diverse platform, and really very cheap that anybody and everybody can use it today. So can that kind of revolution happen here? Probably, because if you look at hardware trends, you see that there was this massive computers, right? And now you have a small one in each of your pockets. And then you saw that in the airplanes. And it was obvious that there has to be something in the ocean that should fill up that question mark too. So this whole idea of a distributed sensor network really made sense if you can make something that is scalable, adaptable, and cheap. And that's what led to me founding a company. It's a spin-off from my PhD research at MIT, called HydroSwarm. And what we essentially make are an intelligent underwater drone platform for ocean data collection as well as exploration. So that egg-shaped little robot right there, that's my drone. It's no more than the size of a football. Very smooth, no appendages or anything. And I'll tell you a little bit later how it came how it came to what it is right now. But the whole point was that looking at design was pretty important for me. As a roboticist, I'm very fascinated. I love robots. And I ponder a lot on the future. And it's important that I think of what's 500 years hence. We have done enough damage. I love technology, but we have done enough damage to the nature. So it's important what you design fits in with the environment. And that's why design was important to me, that is not so disruptive to nature. And even today, the market that it can address is right away a $10 billion market with a lot of trust in seismic mapping to find the right oil and gas size, in defense, in military. And there is prediction about 17 to 25% growth in this particular market. I mean, to give just a big background, what we do is that, this is a generic idea of the drone that we use. It's very smooth. There is no appendages, and there are jet propulsions, basically, so no propellers. And we use a combination of autonomy and propulsion as well as swarm intelligence to do big work as a team. So seabed mapping is definitely one of the applications. And this is, one of the old videos of, the drones in the lab when they were made at MIT. My particular PhD research is on drones that go on surfaces underwater, because surfaces like whether you're looking at ship surfaces or like pipelines, they're rough and you have to glide on them. You cannot, otherwise friction's too much. But you'd be surprised that sometimes we invent something for one purpose and it gets used for something else. This was actually made for nuclear reactors, and my research was actually to toss these drones into boiling water reactor tanks to look for cracks and crevices or detect radiation leakages. I just realized that there was opportunity much bigger than that could be addressed by what I was making. And last but not least, not to sound philosophical, but when I was an aerospace engineer, the thing that really inspired me was I was curious to know what was out there. I was inspired by the beauty, and I was also just wanted to know that, about answers to life in general. And considering, there's this other frontier that has a lot of answers, where the life began, essentially. My fascination is to explore that. For example, this particular video is from NOAA, and they went in 3,000 meters. This is just another life form, like you and me. And I feel that this kind of exploration, just like the Apollo mission of the 1960s that opened a whole new door for space revolution, with the new technologies in deep water, we are going to see a revolution in ocean exploration that we have never witnessed before. So thank you, and hopefully we'll be excited about ocean exploration.
Next up is Jana Eggers. She's the CEO of a startup called Neuralogix. We're now moving a little bit more into hybrid terrains of neural networks and artificial intelligence. Welcome.
Hi, it's really fun and inspiring to be here with folks that are working in robotics. So there's a great overlap between what we're doing on the AI side and the robotics side, in particular in the areas that we're working on in Neuralogix. So our company focuses on a few things, but most importantly, it focuses on recommendations. And if you know something about, so we're out of the Brain and Cog Lab at MIT, another MIT startup, of course. And in particular, if you know something about our brain, there's really kind of two ways that we make decisions. One is we go by habit, which means that we just do what's really normal to us and we don't really think about it. The other is when we actually have to make a decision and we have to think through it. And our brain very, very quickly considers options. So think of us as that second part. We're that part that's helping with the options. What are the great options based on the data that we have today? So that's what recommendations. What's really important for us is that you know why we're making those recommendations. So a lot of systems, particularly the traditional neural networks in AI, very much are opaque. It's hard to see why they came up with this answer. You've probably seen the input layers and the output layers, and then there's magic that happens in between. We work to make that magic very clear. So every single one of our recommendations actually comes with the why reasons as to what drove that recommendation. That's important, especially for enterprises. There's things like we want to do decision support for their employees, but also there's a lot of compliance. So if you talk about any kind of regulated industry, they need to know, why is the computer making this recommendation? Now, the how we do it is the part at the top that's highlighted, is synaptic intelligence. So it's synaptic because, as I mentioned, we're from the Brain and Cog Lab. Our CTO and co-founder did his PhD and postdoc there, and what he particularly focused on is how, why, and at what strength neurons connect with each other. And using that for when they learn new information, that's the intelligence part. For when they learn new information, that's the what we're inspired by is how we do that calculation of what's the weight of a connection between different data and information. So we're using the same computations that he learned from neurons to actually connect data, and in particular to respond to new information that's coming in. So where have we applied this? Really in a lot of different places. I'll be honest, VCs very often say to us, well, you've got to focus on a particular vertical. And I believe that's a go-to-market strategy. It's not the foundation of the company. The foundation of the company is truly about making good recommendations and options. That said, we have focused on that in several different areas. So e-commerce is the natural one. I often get asked the question, when are you gonna make better recommendations? Because the ones from our friends at Amazon or Netflix are very frustrating and they don't fit me. I am happy to talk to you about that during the breaks as to why we believe that, and from working with them as to things that we can improve with that. Some of it is computational power. Government intelligence comes up. Often they want to know this thing is happening in this area. So is it something we should react to or not? There's a lot of signal to noise problem in those type situations. I've got a lot of activities going on. Which ones do I respond to? These are typically solved with expert systems. So another group that we work with is in the pharma industry. And in pharma, they're dealing with lots of things that could go wrong in a factory. And I'll give you an example from a client. You know, they said this factory, any factory, you know, has a bunch of machinery. A machine could overheat at any time. That overheating could be a problem or could not. And they actually build out systems that say, you know, if it's the third shift, we have to worry about it, but the first and second, we don't. And actually in the third shift, we only have to worry about it if it's more than 80 degrees. And we only have to worry about it if it's this machine made by this manufacturer in this timeline, because they fix the problem after that. So that's the kind of thing that we're doing, is we as humans are programming every single feature like that into a system, and then the system can't react to new information or new problems that can happen. So we built a system that can do that, and like I said, I'm not going to go through each of these, applying it in a lot of different places with success. So let me give you a specific example. One of our customers, who's a global bank, they have two separate business units. They have many business units, but two in particular that work in advertising campaigns together, and you guys might be familiar with this. They have a credit card. A few of you probably have credit cards, and they have a merchant solution. So the merchant solution serves businesses that want to take your credit cards. They did not have a way of connecting those folks except for with advertising. So what they would do is they'd say, hey, we have these merchants, they want to advertise. It was just like anybody else advertising. What they wanted to do is, in a more real-time fashion, connect their card members with their merchants. So what they did is they said, I know that I have offers from my merchants, they're interested. How do I find the right people? And where they started was on the mobile phone. And on the phone, what they wanted to do is, someone's walking down the way. I don't want to disturb them anytime, but I do want to disturb them when they'll be delighted. And for me, I'm delighted with chocolate. So it sounds like maybe a few of you are as well. So what they wanted to do is, Jana's walking down the street in London, and right there I have one of my merchants that she could duck into and grab a chocolate bar and have a great, happy rest of her day, which would be true. So what we did is we worked with them on building a system that could learn from ongoing information, credit card purchases that are happening from me all the time, and notify the person via mobile app saying, there's something here that you might like. Duck in here. Now, it sounds easy, you know, well, I get to know you, but we live in an environment where there's a lot of information around, right? I don't want to buzz someone unless I really know they're going to be delighted. So what we were looking at is all types of information. These are just a few examples. And this is part of why it's important that we give the why, is location needs to be very important for this to rate high. If I'm 3 blocks away, that's not going to help me, right? It doesn't matter how much I might want that thing. I'm probably going to be really annoyed and dissatisfied if I get that buzz. Obviously, merchants that are like that, I've got to know a lot of things about that merchant. I may be okay going in a place that's a little bit seedier if it's really like great chocolate, but someone else may not be comfortable with that. And you've got to know the types of places that I go, the diversity of that, to make sure. And it's not just price. There's a lot of things about those merchants that you need to know. Again, I'm not going to go through everything, but we went down into, hey, this person's on vacation. They purchase and have different purchasing behaviors when they're on vacation. So it's this kind of thing where we're taking lots of different information to give them a great answer and a great product for making recommendations to that person. I'm, again, not going to go in detail, but please come talk to us at the booth. We'll talk about all the different places we've benchmarked. We've been live in production. We're live in production with clients. Actually, that one there is in the e-commerce space where we've gotten 40% lift in a very large application there. Collaborative filtering, the 37% is for top 10. We actually do 103% better in top 3 recommendations, which is a remarkable result, meaning that we bubble things much higher to the top. The last one is another live in production solution, which was just a blind test of which recommendations do you prefer. And this was run by Nielsen, and we were chosen 95% of the time. What's also interesting about that is it wasn't in English. This was with an Asia-Pac partner, and so our team actually couldn't even evaluate the recommendations that were being given because they were actually in another language. We have a continuous cycle of learning. So the base graph that we build, it is a graph, is fed by lots of different information being updated all the time, but it does real-time response. And that's the real-time response that it does over here, that everything is scored and ranked. And so when I showed you that 98% rating for Notify, that's when that comes in. So it does both. It keeps a base, just like your brain keeps the knowledge. It then responds with different information, the right information for exactly that, for the response rate. So we have an enterprise platform. I've talked a bit about more consumer, but we also work with an airline, worked with them in their loyalty card program. As soon as their chief risk officer saw what we were doing there, he said, actually, what I need you to help me with is assigning late planes to gates. It's something that they'd never taken into account for, was actually who was on the plane and where they needed to be next. They were always taking into account ground operations, which is a much smaller problem, and now this is the thing that they take into account. So this is the level of problem that we're talking about. We're actually in production in large enterprises, and we are helping them solve their biggest decision problems. So thank you.
So we constantly move between hardware and software at MIT, and a lot of the startups do both. But what we always try to do is the products want to amaze, and one of those places that tries to amaze the most is the Media Lab. The next speaker, Brad Knox, is the CEO of eMotors, and he comes out of Cynthia Brazil's lab, and he was a postdoc there in robotics and social robotics. And I think he has a PhD from U Texas. And he's building his startup out of there. Is that right?
Yep. Thank you, Trond. Hello, everybody. My name is Brad Knox, founder and CEO of eMotors based in Austin, Texas. And I'll jump right into what we're doing. So, The next button on here seems to be mapping to escape. Let's try the other one. All right. So we are making tiny, intelligent, and charming little robots for your desktop, tabletop, or bedside table. These little robots, they love to interact with their owners through things that you say, sounds that you make, through touch. And you can inexpensively get more than one, and they'll play games with each other, interact with each other. And then you can also interact with them not only directly, but through their environment as well. So a very new form of interaction. And before I get into how we're making it, I'm going to backtrack a little bit to the origin. So here I am in the Media Lab. And when I was there, the grad students and the postdocs, some of us would get together and gripe because we were all there because we had different but similar visions of wanting to build robots that we personally wanted to interact with. And not only had we not achieved that, nobody had. None of us had robots that we wanted to interact with on a daily basis. And so we were asking this question, where are our robot companions? And I actually took a step back and asked a somewhat simpler question, which we still didn't have an answer for, which is where are robot creatures? And there have been some really marvelous attempts at products for lifelike robot creatures, but really there hasn't been a successful product that at a mainstream level delivers this illusion of life that fascinates, entertains, and delights us. I took some time to think about why and came up with this list of some common limitations of these previous efforts. So for one, their form often sets high expectations. So if the robot looks humanoid or dog-like, you expect it to be as smart and intelligent and act like a dog or like a human, and we can't deliver that yet. Another thing is they often are high cost, they require manual recharging, or if they have a charging base they can find, they can only find it some percentage of the time, like a Roomba if you have one. Also, usage data is not collected with most of these products by the companies. They often have slow movement or repetitive behavior, which means that they often end up seeming less organic than they could, and also getting old more quickly than they should. And then lastly, partially because of the recharging issue, they only interact with their users. They don't actually have a life of their own. When you leave, they're just inactive. And that really hurts the illusion of life too. So that's robotic creatures, but interestingly, virtual creatures have had a lot of success. So I'm guessing many of you are familiar with Tamagotchi, definitely a big hit. But since then, there have been a lot of other successes. So for instance, Nintendogs here, the second one, it's the second best-selling video game series for the Nintendo DS, which is the second best-selling video game console of all time. Some other successes here, and now virtual pets and virtual creatures are represented mostly in apps, where one estimate had that 5% of the top 300 grossing iOS games were virtual pet games. So this is a continued success here. Now, on the other hand, there have been a number of studies by human-robot interaction researchers showing that when you compare a physical and a virtual character, where the only difference is the physicality, the physical ones result in more enjoyment, and they're treated more like a social partner. So putting these two things together, we've got that virtual creatures have been successful. Physical embodiment really makes people see it more as a social entity and more lifelike and enjoy it more. And there's a big opportunity there. So the question then becomes, how can we realize this opportunity where previous efforts have failed? So at Motors, we are following a set of design criteria that you'll see harken back to that list of common limitations. So first, we want highly organic behavior, and I'll talk about how we do that through machine learning. We also want the robots to be, quote, always on, except when they're sleeping, basically recharging. So they should never be just off. They should never have a depleted battery. I'll talk briefly about that. They should also have their own life. If you go on vacation, they should still be active, interacting with each other, their environments, and so on. And they should set fulfillable expectations by their morphology and their behavior, expectations that they can possibly even exceed. And then lastly, they should be affordable. So to make this highly organic behavior, we're using the research that I did with Cynthia Brazil at MIT, where we had a human puppeteer a robot while it interacted with a person, and the person didn't know that it was being puppeteered. From that puppeteering, we would gather data and apply machine learning, so we'd end up with a model of the puppeteer. And this model, importantly, captures the flow, the spontaneity, the play of the puppeteer in a way that really isn't going to happen if you do the more traditional way of defining a character, where you sit back and make rules or imagine what the character should do in certain situations. And we found that we found really positive results in terms of how the subjects in our studies responded to this and how organic it just subjectively seemed to us. We also wanted these robots to be low cost, but have high intelligence and interactivity. And we achieved that through the Internet of Things platform, where this platform serves as the eyes, the ears, and the brains for these robots, wirelessly controlling them. And what that actually translates to is there's an overhead camera, a microphone, and a computer in this platform doing the perception and the decision making for these robots. And what that achieves is a number of things, but two important ones. One, because we know exactly where the robot is from the camera and exactly where the charging station is, we can get it back to the charging station with super high reliability so that the actual user effort to keep this a persistent and alive part of your environment is very little. Also, it allows the individual robots to be inexpensive, diverse, and collectible. We're working with our partners PushStart Creative to actually finalize the designs on these. And here are a couple of the designs that we're currently exploring. So these aren't final designs, but they're ones that I'm particularly excited about. Compared to what else is out there, Emotor's robots really maximize illusion of life and long-term, and we're aiming to design it to support long-term usage. So really trying to combat the issue with a lot of existing electronic characters where they get old fairly quickly once you get a feel for what they do. We also, another differentiating factor is that they're fully Internet of Things, always internet connected, affordable, and they're fairly unique in that we're designing them to appeal to a wider audience than just children or the elderly in nursing homes. We have a wonderful team, including Dr. Eric Zaveski, who has a PhD in computer vision from Columbia. There's me. We also have Heather Campa, Jonathan Giorgino. Jonathan was actually the only electrical engineer for Wonder Workshop, which some of you guys might know as the toy manufacturers and designers of Dash and Dot, which are these kid-oriented robots that have been fairly successful. And then we have a wonderful collection of advisors and partners. So I talked about companions at first and then backtracked to creatures. And this initial product, our goal is to maximize illusion of life, and we're calling them creatures. And I think that's going to put us fairly squarely in the toy domain. But really, we want to move beyond that. Entertainment, delight, fascination, those are important values to give to people. But we really want to move towards companionship. And when we do that, while I don't necessarily want to call these pets, they're going to be very similar in that they'll be non-human, non-verbal companions. And so if you look at the pet market, it's much larger, 3 times as big in the US than the toy market. And there are all sorts of people who can't have pets but would like to have pets. And in a recent survey, the 10 of the top 11 reasons people gave for why they couldn't have a pet, those were addressable reasons by robots. So if you're a skeptical person like I am, you're probably wondering, can people actually bond to digital creatures? Is this like kind of a romantic notion? Is it just overly inspired by sci-fi? And surprisingly, the answer is already that some people do. So Sony Aibo, last year, Sony stopped repairing the Aibos. And the New York Times and many other venues covered these funerals in Japan of people. And in the video, they talk about their family dog. And this is a real formal funeral. And these people are serious when you look at them. And there's nothing noticeably abnormal about them either. And if you backtrack to when these were released, these robots have been running for 10 to 16 years. And while this didn't happen in every household, these are people who really are taken by these Sony Aibos. Also, there's this documentary from a little while back, maybe 2008, I think, where it covers Pero, the $6,000 robot seal for nursing homes. And this elderly German woman, she lights up whenever Pero is around. It's just night and day. And it's just a really impressive case study of what can be done with a robot and for the right person and appropriate design. I'll skip this last one for time, and I'll end with a video of some of our user testing. So this is teleoperated robots, but they don't know, and this just shows the first movement and how people respond to it. So one thing that I find particularly compelling about these videos is that from the still robot, let me actually say really quickly, yeah, this guy's great. The way they look right now, that's all engineers doing the design, which I'm proud of it being not too ugly. And I'm really looking forward to when we have the professional designers get in. And I want to point out, so she's about to apologize to it.
Oh, sorry.
And I think that's just a really amazing illustration of this is a machine. She knows it's a machine. But in the same way, when you watch a cartoon, you can feel that it's real. And she had this spontaneous urge to apologize to a tiny little robot running around in front of her. So I'll end with that. And I'd love to talk to anyone who has questions or is interested in talking about a possible partnership. And thank you very much for listening.
So as always, we're bringing these startups to you not just to wow and amaze you and have you think about future possibilities, but they you know, as indicated here, all of them are here to achieve something. They are interested in partnering with you as a corporate, perhaps with a startup, perhaps with you as an individual. So do not hesitate after this is, you know, we're going to go for a break. You know, come over to them and see what you can contribute. This is not just a passive event. We are very interested in there being real, live, forged partnerships between humans and humans or humans and robots. We are partial to both here at this event. The next speaker, Todd Mostak, is the co-founder, CEO of MapD. He's a former researcher at CSAIL, which is the Computer Science and Artificial Intelligence Lab at MIT. Stage is yours.
Thank you, John. Hi, everyone. Hey, everyone. Great to be here. So I'm not going to talk about something as exciting as robotics today, but maybe something almost as exciting, and that is GPUs. So I basically kind of got into the realm or world of GPUs. I was actually doing my graduate school research on Middle Eastern studies at Harvard, basically harvesting hundreds of millions of geocoded tweets and trying to do different types of social media analytics on these tweets, GIS, NLP, and basically found that conventional systems weren't fast enough to keep up. And so I started getting into GPUs, took a database course at MIT, and voila, you know, out comes MapD. So why do GPUs make so much sense for the enterprise? If you basically, I think we're actually using an old deck here. It's okay. So if you basically look at your common CPU, right? If you're running analytics on a CPU, you have 10, 20, or 30 cores. You compare that to GPUs, right? And you have maybe 40,000 cores per server. That literally means that you can actually process 40,000 rows of data in parallel, simultaneously. And the speed increases are pretty amazing when you do that. So what MapD does is it takes advantage of these GPUs. It basically uses up to 16 of these GPUs per server, and it's a database and a visual analytics system. So it's a piece of software that basically harnesses all this parallel power, basically this supercomputer in a box, and it gives you 100x faster queries, it gives you live visualizations, and basically gives you a supercomputer in a small 3-4U box. Actually, one of our customers, Verizon, benchmarked us against a 20-node Impala cluster. Impala is an in-memory database, and basically found that we took 160 milliseconds across 3 billion rows. Impala took 20 seconds. So that was totally the wrong deck. That was like a year-old deck, maybe from the last time I gave this. Is it all right if I switch to, I have it here on my computer. So now I'm going to give the presentation I was supposed to give. Great. So as I mentioned, the speed differences are pretty profound. So these are some more benchmarks comparing against 3 to 10 node clusters of various databases, and the last one is Impala. And you can see here that, you know, basically we get these 30 to 100x speedups, which is really huge because, you know, some of these queries on this other systems are taking 20, 30, 50 seconds. So you cannot call anything that takes 30 seconds interactive. That kind of speed, you have to get up, go get a cup of coffee, come back, hopefully the answer to your query is there. So if we can do it in 100 milliseconds or less, that basically means speed of thought kind of analytics. And the business impacts are profound. So basically teams, if they know that their queries are going to take too long, they're only going to answer, or ask the questions that they know they can answer. Analyst creativity is impaired. Nobody likes waiting for their machine. People are just going to give up. So MapD doesn't just get its speed by using GPUs. So to start with, we do a few kind of cutting edge things that make sure we get the most out of the hardware we run on. First off, we compile our queries on the fly using something called LLVM. So it allows us to approach the speed of handwritten functions. And second thing that differentiates us is we actually are running on graphics cards. Obviously, the graphics cards were originally built to run video games, rendering millions of polygons to the screen. We can actually use them for what they were originally designed for and basically take all that graphics horsepower and leverage it for data visualization. So you can imagine pushing a SQL query through the GPUs, taking the results, and without copying it back to the CPU, we can actually render it in place using the graphics processors and send back to the client billions of rows of data rendered as a PNG that only takes 100 kilobytes instead of potentially gigabytes. And finally, we find that MapD has very big geospatial implications. So we have a lot of geospatial functionality because often geospatial analysts, whether they're working with, say, Facebook, one of our customers is Facebook, they use this on Instagram data, whether it's Verizon with call log data, a lot of geolocated ad tech data. All of this stuff demands heavy-duty, fast geospatial operations. So where does MapD sit in the overall ecosystem? So we're not designed to be your database of reference, right? If you have a Teradata or some other data warehouse, or you have Hadoop as your data lake, you should keep that. What we do is we go alongside it. We act as an accelerator or supercharger for your existing data store. So you can pull data out from your system of record. Alternatively, you can stream data in. Another strength of MapD is that we can stream data in at very fast ingest rates. Basically, because we have this supercomputer in a box, we don't have to index like traditional databases, which means that we can get very, very fast ingest rates. So at Facebook, we in fact ingest the Instagram stream in real time. So once the data is in MapD, you can either consume it like a traditional database through ODBC or through command line querying, or traditionally what you'd use is MapD Immerse, which is our visual analytics front end that basically works hand in glove with our back end to deliver instantaneous visual data exploration. So in closing, I'm going to do a brief demo after this, but in closing, why do GPUs make sense for analytics? People have been using CPUs for so long, and obviously they're ubiquitous, but at some point it's not the right tool for the job. So GPUs have more speed, they're cheaper if you look at like how much hardware you have to buy to get a given speed. They're more power efficient. And finally, GPUs are on the wave of kind of the next, the big trend in machine learning is towards deep learning, or neural networks, and that's something we're starting to experiment with as well, where you can actually run neural networks right on these GPUs to get the insights you need. So with that, I'm going to cut to a demo, hopefully. So here's an example of our system in action. This is our live tweet map. So this is a relatively small data set for us. This is 145 million tweets. Here you can see different aspects of the system at work. So we have a timeline, we have the top languages, we have the top hashtags over here. These three things are rendered on the front end. What's cool is this map, though, this visualization is actually an example of GPU rendering. So you wouldn't want to move 100 million tweets to the front end to render. You would be sitting here all day waiting for it to come over the network. So instead, what we do is we actually do the SQL query on the back end and then render those results. So everything is fully interactive. So I could click here, I could click Brexit. So you see this big spike. You can actually look at any of these tweets, see what people are saying. The interesting thing here is if we switch to choropleth mode, you can actually see this is the percentage by country talking about Brexit. Germany is actually talking about Brexit more than Britain. I think it's a little bit of sour grapes. So what's cool here, and I hope this works, I'm going to do something I probably shouldn't do. So I have my Twitter thing out. I turned my geolocation on. As I mentioned, this was live. So I'm going to take a photo. Let's see. How do I turn it? All right. Okay. So I'm going to tweet this. Oh, oops. Well, people, you can also feel free to tweet. You have to turn your full geolocation on, right? So you have to go into the geolocation and actually say, share my exact location, which is a little creepy, and then you might end up on our map. So I'm going to zoom in here to San Diego. And let's see. I think I searched. Oh, there we go. So here we are, live. So we can stream all this data in real time. And if we click here, we can probably see this awkward photo. Of course, we could clear out and see what everybody else is tweeting around here. So it gives you some sense of the system. We do a lot more than that. This is our standard kind of BI point and drag dashboard. So you can see this is 120 million flights. As I drag over, it's incredibly interactive. I just built this dashboard on the fly. Show you something. This is actually not a feature, but just to show you what's going on behind the scenes. As I drag this time bar, you can see all these queries going over the wire. Each of these charts updating is hitting the back end. I think this is a single GPU. It's hitting the back end and basically running a full SQL query over the data. And you can see 25 milliseconds, 24 milliseconds, 11, 18. The reason why we can be interactive like this is just simply because the back end is so fast. And then this is a fun demo. This is the last one. So this is all political donations from 1990 to 2014. So I'm going to zoom to New York City. So you kind of get this idea that everything here is cross-filtered. So as I zoom in, everything changes here. So I'm going to zoom into New York. I could compare, say, Barack Obama versus Mitt Romney. I could zoom in on 2012, and then we can actually go down to individual neighborhoods and see actual individual donations. So again, the reason why it's so fast is because we have so much horsepower on the back end. Why we can create these kind of immersive visualizations is because we have the GPU rendering power. And here's a fun one I'll leave with. So I'm going to search for Trump. So we actually don't have we don't have the latest election cycle. So here we go. We can see his donations over time. We can look at his various palaces. Shouldn't say that. Okay, so as I scroll through time, you can see he originally gave to Democrats, but as we move forward by the end of the time range, actually here in 2008, he gave both to John McCain and Hillary Clinton, a good businessman, and then by the end, he is almost entirely Republican. So he made his metamorphosis. Cool. So this is an example of our system in action. Come see us at our table. Happy to give more demos. All right, thanks so much.
So as a good man, he reminded me that I haven't told you what the STEX hashtag is, but it is STEX San Diego is the hashtag, and our Twitter handle is MIT STEX, MIT STEX. So that said, next up is Loel Odner from Right Hand Robotics. And so we are back in the robotics domain, but I think you saw quite clearly, and I think this workshop, we wanted to bring both robotics and analytics into the same environment, because I think everybody realizes that it is a combination of those two domains that's going to yield the most results, and I'm hoping Lyle can explain some of that too.
Thank you, Trond. So today I'd like to talk about one of the hard things in robotics. We have seen today, and I think you've probably all seen over the last couple of years, a lot of absolutely amazing robotics companies coming out. And there are a lot of people making self-driving cars, a lot of people making drones, sensor networks, personal assistants. And one thing that should stand out at you about all of these is the approach they take to planned physical interaction, which is to say they don't plan to physically interact with anything. You know, if you're a self-driving car, you want to interact with the road. Any other objects you track, you're pretty much trying to avoid as obstacles. Or even if you're locking on something to video it, you want to follow it but not make contact. So we are aiming to change that. My company, Right Hand Robotics, which I started with a couple of collaborators in 2014, is dedicated to the problem of manipulation and interaction with unknown objects. So what you're seeing here is my co-founder, Leif. He's walking around Boston with a robotic gripper that we designed for DARPA. And what he's doing, he just has a simple interface. He has a trigger on there. And when he pulls the trigger, it closes on an object. It has tactile sensors all over the hand, so it can detect only when it makes contact. Oh yeah, they for health reasons, they had to make us wear gloves on our hand. And yeah, with that, with no computer models, with no high bandwidth control, he is actually able to grasp and manipulate a wide range of objects that he has never seen before. This, if you think about it, this is sort of the Holy Grail. This is the thing that robots can't yet do. And I think you can all imagine the multitude of avenues that would open up if we had such a thing in practice as a reliable, repeatable technology. So what I'm going to talk about is the area that we see the first immediate opportunity, and that is e-commerce. I think one of the first reasons why e-commerce is an opportunity for us is just that it's growing. It's growing by double-digit percentages every year. This is largely a customer-driven problem, so the customers are preferring the very clean, streamlined experience of shopping online rather than going to a big box store. And the thing about that is, although the demand is there largely because of this very clean user interface, when you go to the back end of online logistics, it's not clean at all. So most people think, when you click on something to buy it, that a little robot is going to come out and pick up your thing and put it in a box and mail it to you. And in reality, what these warehouses really look like is, imagine all of the stocking clerks from all of those big box stores that you no longer go to. Imagine them now all crammed in a warehouse. And they are walking around and they are picking your orders. And this is, well, first of all, it's very expensive. Second of all, they're jobs people actually don't want to do because unlike the big box store, which used to be located fairly close to the customer, these stores are now located out in rural areas. So here in California, they're out in the desert. On the East Coast, a lot of them are in central Pennsylvania or central Ohio. So what we found is there's a huge problem in getting people. Now, the thing that's driving this on the back end, the thing that's driving this demand for labor is actually a transition from moving pallets and cases in warehouses, which is something that people are well familiar with doing, to moving individual pieces, individual products. And the thing that you have to do once you get to moving individual pieces is you have to get below this nice abstraction barrier that pallets and cases provide. So you see, a case is a roughly uniform blob. You can stick a tray underneath it to pick it up and manipulate it. However, when you move to individual objects, all bets are off. Just as a final point here on customer need, we've talked to a lot of very large retailers. They predict they will be out of labor for some of these regions where they're serving in the next 5 to 10 years, and many of them closer to 5. Currently, they're dealing with situations like 20% absenteeism because they're jobs people don't want. They're also dealing with problems of churn, so workers only last a few months in these jobs. They typically don't stay in one place. And I don't know if you've seen the BBC documentary, The Truth Behind the Click. Regardless of what you think about their claims, it's definitely the case that people are preferring other jobs. So people would much rather work in an air-conditioned call center than in a warehouse. The problem then, of course, is how do you replace these people, or how do you plan for growth that involves people opting out, which is the reality of the situation. Traditional robots are mostly designed for manufacturing. They're designed to do the same thing a million times in a row. And as a result, they're usually very pre-programmed and pre-integrated. So when you're picking up one object, you'll hire one person to design a custom gripper. You'll hire one person to program the system for that. You'll have a CAD model of the thing you're picking up. If you go into a warehouse with 10,000 stock keeping units, you can imagine that it would be pretty much impossible to scale such a system to pick up every item in your warehouse. And that's our company's vision. So we are making a completely autonomous system for picking unknown objects without computer models. And I'll just dive right into the video because that's really what all robotics presentations should be about. What you're seeing here is an early version of our robot. It is picking objects out of an automated storage retrieval system, so these bins just come up to the pick station and stop, and the robot's just commanded to take one of whatever is in this bin out and put it into the service area over there. Now, you don't have a CAD model for a potato. That's one of the reasons why we use these. We also tried to highlight here, you can see there are many different kinds of packaging. Some of these are deformable packaging, those foil packs, and some of them are boxes. And the robot doesn't care. The robot analyzes each one of these, and it figures out what properties of it make these items graspable, and then picks the item it is most likely to grasp out of the bin. So I'll repeat, it knows nothing about any of those objects. Now, I'll go over this very briefly because we're not saying much about what's inside this. What I will say is our team started with a great background in hand design. We were working for a DARPA program, making hands for robust manipulation and ordnance disposal, things like that. That's a very critical piece of the puzzle, and we've been working on it for about 10 years. The things that have really enabled us to commercialize this is the emergence of dirt cheap computer vision. You can buy today for a couple $100 a sensor you couldn't buy for $20,000 10 years ago. It's really transformed everything. And then the third piece is we've labeled it grasp intelligence here. And what that really means is, this is what we talk about with planning without models. This involves a great deal of machine learning. It involves motion planning from vision, and a lot of the difficulty or a lot of the secret sauce is in how you fuse machine learning into planning motions out of the kind of features you get from these cameras. So we are principally a software company, actually. So where I'd like to leave you with this thought is, we like to talk at our company about the other Internet of Things. So people talk about objects as servers all the time. We like to think about what you could do if you could treat the objects as data. Imagine if you could take millions of everyday items and you could route them anywhere in the country in any quantity, either case or individual items, and you could do so in a way that was automated and optimized. And we see what we're making here as basically the piece-level router for this other Internet of Things. So with that, I'll thank you for your attention, and if you want to come talk to me, I'll be out front after.
All right, last up, before we're going to release you to some amount of break, but also a startup exhibition with 11 great startups, some of whom you've heard from and others that you'll hear from later in the day. I am happy to introduce Alok Tai from Tetra Science, who I think will close the loop on some use cases that we haven't heard about before on automation and IoT. Thank you.
Hi, everyone. My name is Alok Tai. I'm the CEO and co-founder of Tetra Science. We're a team based in Boston that is leveraging the Internet of Things to drive automation specifically in scientific research. Now, for us, this is actually a problem that we have sort of deep interest and passion in. So for me, I was born and raised in Albany, New York. But unlike most folks where I grew up, whose first job is delivering a paper door to door, for me, however, at the age of 15, 16, my first job was actually doing lab automation for nanotechnology. So I started very young building hardware and software to test, at the time, nanomaterials and how they interacted with dangerous chemicals. So from there, for about the past decade and a half, I've been working in this domain of leveraging automation, but to drive scientific productivity. But ultimately, now with revolutions in both connected devices, as well as cloud software, we've assembled a team of now about 24 people based in Boston with MIT and Harvard heritage. About 30 years of R&D experience across us, from chemistry and biomaterials to optics and sensors, who are now focused on trying to leverage cloud technology and IoT to drive greater productivity in research labs and move the forefront of innovation farther and faster. But ultimately, the way this sort of manifests in our domain is that what we're doing is basically building a mission control for laboratories. In the same way manufacturing facilities have SCADA systems for manufacturing process control, we're bringing that same level of insight and control to the laboratory, where a research lab can now remotely monitor and control their instrumentation, automatically log all the data, but then also quantify metadata like instrument utilization. And so we've been doing this for a little bit of time now and work with some of the largest pharmaceutical companies, oil and gas companies, and academic institutions. But the reason we're sort of working in this area and trying to bring cloud to this domain is because many of the processes that drive new medicines, plastics, greener energy haven't changed in the past half century. As you can see from the image, which is really characteristic of a current lab today, many of these processes are manual and done in person. In the case of, say, even imaging, much of it is done in person, and data is captured either via pen and paper or on a USB drive. It's unbelievable. So much waste goes into it, and as a consequence, about 45% of all R&D dollars, as a consequence, are wasted. Now, these inefficiencies result from deviations where experiments fail and no one has any idea. They result from data management issues, where for every hour a scientist spends doing an experiment, they spend another hour managing the data. But then lastly, they simply postpone experimentation and postpone their projects because they can't physically be there to perform specific tasks. Now, one might think that these are just small issues that are relegated to one sector. But in fact, when one actually looks at the $250 billion that are spent in preclinical type workflows, that's biology and chemistry, across pharma, oil and gas, food, chemicals, it adds up to a quite large number. But one might ask the question that if we have SCADA, for instance, in the case of manufacturing, why don't we have this sort of capability in the laboratory? But like any business process, research is based on producing good data. Ultimately, this data is produced by instrumentation. Now, in our industry, there's over $44 billion a year spent on scientific instrumentation globally. The problem, however, is that that money is spent across 2,000 different suppliers. This element of fragmentation manifests where the number one player only owns about 20 to 25% of the market. The top 50, 50%. So it's this element of fragmentation which has resulted in disparate systems that don't all talk to one central piece of software. And so as a company, this is where we're bringing in this concept of IoT and the consequential automation of both the prosecution of the experiment, but also its analytics. And so fundamentally for us, IoT and our thesis is not that IoT is going to become one solution that's spread across every single industry, but instead it's going to become vertical to vertical specific. The reason for that is that ultimately the connectivity nowadays, as the folks from Qualcomm has mentioned previously, is a commodity. It only creates value when the connectivity is combined with a workflow innovation and a business model that's relevant to the end user. And it's that package that's specific from industry to industry, vertical to vertical. And that's why we're focused specifically on scientific research. So ultimately, thinking about this package, what we've done is basically created a network of smart, cloud-connected instruments that digitize and automate the manual processes associated with experimentation, data collection, and analysis. We'll connect a myriad of instruments, that ecosystem of instrumentation that exists in a lab, connect it to the TetraScience R&D cloud, such that a researcher can in one place access the real-time data stream visualize it, and then also analyze it. And so as a consequence, what we've done is built a solution that allows us to take the existing installed base of capital equipment using our own little gateway, which we call TetraScience Link, which you can see in the bottom right-hand corner. It can connect to the RS-232 or USB port of an instrument, or even a sensor, and then brings the data from that device either via Wi-Fi, Ethernet, or cell service to our cloud-based dashboard. That dashboard can then be deployed, whether it be on a mobile, tablet, PC, for the user to use. And ultimately, that core set of functions, which is again data production, monitoring, control, alerts, and data capture, can all be done from our central system. And so given that there's so many different types of research and so many different points of value, what I want to do is sort of walk you through an example case study. So we're actually working with one major $40 billion pharmaceutical company who was actually about a year ago trying to bring a new drug to market. So they had one last experiment to perform before they can actually go directly to manufacturing and bring that drug to market. Projected revenue for that drug in year one was about $2.2 billion. However, the experiment they had to run was a stability test where they had to take multiple different pieces of data, periodically walk up to a machine with a USB drive and pen and paper to capture that data over the course of a 2-month-long period, synthesize it, analyze it, and then ultimately report it to the FDA to prove safety and efficacy and stability. But as you can imagine, with any manual process that's done at a person's request, there exists a whole host of inaccuracies, inconsistencies, and also inefficiencies. Interestingly, a month and a half into the 2-month-long stability test, the cleaning crew came in to buff the floors and turned off one of the experiments. Thankfully for them, they had TetraScience. What we did was we actually enabled them to real-time monitor and capture all the data from that experiment, log all of it, but then also notify them within 10 seconds of the deviation. They were able to come in the next day, save that compound and that experiment, and take it to market a full quarter in advance of what they could otherwise. Wall Street credited them with a 6% bump to their market cap, which corresponded to about a $2.5 billion increase in value of that business. So there's some really powerful ways in which IoT can help automate and digitize a lot of the processes that exist in laboratories, which historically were manual and relegated to pen and paper. And so as a company, because of those value points, we've started to build an ecosystem of manufacturers that we can support and partner with, where later this year you'll be able to buy TetraScience connected units from some big billion-dollar manufacturers down to small startups. And so we're also backed by some of the best investors on both coasts. We went through Y Combinator this past summer, and would be happy to chat with anybody about our technology and long-term vision afterwards. Thank you very much.